Have you ever wondered how a smartwatch counts your steps, receive notifications, and even monitors your heart rate and still responds instantly when you touch the screen? Or how a modern car continuously checks hundreds of sensors while controlling the engine, airbags, ABS, and the infotainment system all at the same time? The interesting part is that the microcontroller inside isn't actually doing everything simultaneously. It only has one CPU. So now let's wonder, how is it able to handle so many different jobs? That's exactly why real-time operating system or simply RTOS were created. Let's understand this with a simple example. So yes, now let's start learning. So imagine you own a small restaurant and you are the only employee. So now a customer is walking in and is going to order a pizza. And while the pizza is getting baked, other customers arrive asking for a pasta. At the same time, the phone rings with the delivery order. Someone else wants to pay their bill, and another customer asks for water. Since you are working alone, you decide to finish one job completely before starting the next. You prepare the pizza, then the pasta, and then answer the phone, then process the payment, then bring the water. By the time you reach the last customer, they've been waiting far too long. Some customers leave, some gets frustrated, business starts suffering. This is exactly how a normal embedded program works when everything is placed inside a single while loop. The processor keeps one thing. If one operation takes longer than expected, every other operation has to wait. Now imagine hiring a restaurant manager. The manager doesn't cook the food. Instead, they organize everyone's work. Now, as you can see here, yes, as you can see here, a single restaurant can't get everything right. The kitchen would be getting overwhelmed and the task won't be cleared regularly. So, as I said before, when I'm going to hire a manager, instead of one huge program doing everything in order, your application is divided into multiple smaller tasks. Let's take a small example. In our task, one task continuously reads sensors. Another task, it is going to update the LCD display. The third task sends data to the cloud. Another task is going to control the motors. And finally, why not? Even I'm going to add another task which is going to check the emergency condition. So each task has its own responsibilities. As you can see here, I can do many responsible things inside a single code. So I don't need to create a single while loop which consists of every code part. That's the main thing in RTOS. So the RTOS scheduler actually decides which tasks should run and when. It not only segregates the required tasks, it also decides who have to be running. So think of the scheduler as a traffic police officer standing at a busy intersection. It doesn't drive the vehicles actually. It simply decides who gets the green signal next. Fast moving emergency vehicles gets the higher priority. The vehicles which is going to move slow will be getting the lower priority. Similarly, an RTOS gives important tasks higher priority. So now imagine you are designing a medical heart rate monitor. Every few milliseconds, the heart rate sensor must be read. Missing even a few readings could produce incorrect results, right? At the same time, sending data to the cloud can wait for a second or two without causing any problem. So an RTOS understands the difference. It makes sure the heart rate monitoring task always run first, while less important task is going to be executed later. This ability to respond within predictable timing is what makes an operating system real time. So basically, real time doesn't necessarily mean fast. It means it is going to be reliable. The system performs important tasks within a guaranteed time limit. That's why RTOS is widely used in industries where timing is going to be very much critical. Cars, medical devices, industrial robots, drones, spacecrafts, etc. So without an RTOS, developers would have to manually manage all these operations inside one massive loop. As project becomes larger, the code becomes harder to understand, harder to maintain, and finally, much more difficult to debug. So, an RTOS solves this by organizing application into independent tasks that works efficiently together. So, in the upcoming lessons and videos, we'll see how free RTOS create these tasks, how the scheduler switches between them, and how tasks communicate safely without interfacing with each other. Once you understand why free RTOS exists, learning free RTOS becomes much easier because you are no longer memorizing functions. You understand the problem they were designed to solve. So, thank you.